Hello students, welcome to Calculus 1. Even though this is Module 2, this is the de facto starting point of calculus, limit and continuity. We begin with a couple of motivating examples, and here's the first. Please take a look at this graph, y equals to f of x, and please find out appropriate property regarding the continuity. I didn't tell you the mathematical meaning of the continuity yet, so please rely upon your common sense. Just dictionary meaning will do. I can see three continuous pieces here. Left hand side, when x is less than -4 here, and then the middle part, x is greater than -4 but less than +3, the middle part. And finally, when x is greater than 3, the third part here. We have these three parts. Three continuous pieces, and those are separated by two breaking point discontinuities at x equal to -4 right here and x equals to +3. How about the next problem here? Again, my question is about continuity. How many pieces do you see? I see three again. Here x is less than -2, one continuous piece. And then between -2 and +1, we have the middle piece. And then when x is greater than +1, we have the third piece here. They are separated by two breaking points, or vertical asymptotes in this case, x equal to -2 and x equals to +1. Those kind of things are continuities, but of course, what we want to do is to make these concepts more rigorous mathematically. That's what the limit is all about, and we are about to begin. Ready? Let's go. We use this kind of notation. We say the function value f of x converges to L, a certain number L, as x approaches to c, and we write like this. F of x converges to L, or f of x is going to L as x is approaching to c. Well, this expression is rather vague. This one is a little bit more rigorous. Limit as x is approaching to c, f of x is equal to L. Again, limit as x is going to c, f of x is equal to L. And we're going to use this notation over and over again. Let's go back to that graph and let's discuss that using that notation. And let's find some appropriate c point. How about c equals to -2 right here, x equal to -2. Okay, let's consider that. X is approaching to -2, f of x, what is it? Oops, wrong key. Okay, this is about approaching, so we have to find out all those parts of the graph, and then we have to approach toward x equal to -2. I can approach from the right hand side like this, or from the left hand side like that. Either way, I'm getting the same y-coordinate value, y equals to -1. Do you see? What if I select +2 here? Okay, let's go ahead and do that. How about that? Here, x is approaching x equals to 2 from the left hand side or to the right hand side. Either way, I'm going to get the same y-coordinate value right here, which will be 1 and 2/3. I'm getting 5/3. Is that clear? Okay, let's consider this time a little bit bad point here, x equals to -4. That'll be a little bit more interesting. Now let's consider the limit. So we have to follow the graph. I can follow from the left hand side and getting closer and closer to this. Which y-coordinate am I converging to? Or I can follow the right hand side of the graph and get closer and closer and closer as I approach x equal to -4. Which y-coordinate am I converging into? Remember, the function value is y-coordinate. Therefore, the limit should be y-coordinate. Which y-coordinate? It's 1. Now, how about the function values, by the way? When x equals to -2, what's y-coordinate? Look at this. And what do you get? Y-coordinate is -1. How about f of +2? When x equals to +2, what's the y-coordinate of this point? 1 and 2/3, so 5/3 again. How about f of -4? Where's the graph? It's right here. Not down there, but right here, because this part is empty. And for the function value, I'm looking at just single point at x equal to -4. What's the function value? What's the y-coordinate? That's 3. Now let's compare those with limits. These two, we have the same y-coordinate value. This one, we have different y-coordinate value. And can you see that from the graph? Function value is the single point. That's point property. And the limit is a local property. We have to look at points nearby. We have to follow the graph and which y-coordinate is it approaching? Which y-coordinate is it converging? It's converging into y equals to 1, not 3. So we have two different values. Not coincidentally, we have discontinuity here, and then these are all continuous points. Let's go back. We just discussed the limit, and let's go over to continuity concept. If the limit and the function value are the same, we say continuous. Otherwise, they are discontinuous, and we just saw an example there. Let's go back to the motivation example again. These kind of points, continuous because function values and limit are the same, but here, two different values, we have discontinuity. That's x equal to -4. There's another bad point, x equals to +3. Let's look at that now. Okay. In that case, we have to consider two different limits because I can follow the graph from the left-hand side and I can follow the graph from the right-hand side, and I'm getting two different y-coordinate values. What do you mean by that? That's what the one-sided limit's all about. It is possible to have two different limits as it follows the graph from the left-hand side or right-hand side. Those are one-sided limits, and we use this kind of notation. C minus, that means negative side. C plus, that means plus side. In mathematics, negative means left-hand side, positive means right-hand side. That's how the number line looks like. So this is the left-hand side limit, and that's the right-hand side limit. Basically, we are looking for the graph and following the graph from the left-hand side, and then following the graph from the right-hand side, and of course, we have to read the y-coordinate as usual. Let's go ahead and do that. Let's see. I don't want to lose this, so let's consider these over here. Excuse me. I clicked the wrong key. Okay. Going to +3 from the negative side. So follow the graph from the left-hand side and getting closer and closer x equal to 3 and approaching which y-coordinate value? Again, follow the graph from the left-hand side and converging to which y-coordinate value? I'm getting y equals to 2. On the other hand, take this part of the graph and then follow the graph from the right-hand side toward x equal to 3. Again, following the graph from the right-hand side, which y-coordinate am I converging to? That's -1. As usual, the function value limits, all those are y-coordinate. X is going to 3, either plus side or minus, and what you're reading is the y-coordinate value. Now how about function value at f is equal to 3? You have to get the point, and point is right here. And that's positive 1, isn't it? What do you see? They're all different. There's no way we're going to have continuity. To the left hand side we get this high, to the right hand side we got that low. They're not the same. As you can see, we have that breaking. And function value is 1, but I can move that point, and then this value will change if I move that point. But the other, this left hand side and those right hand side, they'll not be affected. Those kind of things are one-sided limits. Let's recap all that with this comprehensive example problem. Same graph, yeah, intentionally I selected the same problem, and let's work on it. Special point x equal to -4 is here. Alright, what's the function value? You have to find out a single point, right? This is function value. So y-coordinate value of that point here, that's 3. Okay, now left hand side limit, so this is -4 minus. So follow the graph from the left hand side. Which y-coordinate is it converging to? It's converging to y equals to 1. Now -4 plus, so it's plus side. The right hand side, which y-coordinate value? Again the same, y equals to 1. And what about the limit itself without plus or minus specified? If these two are the same, then the limit exists. We'll say 1. How about the continuity? All these have to be the same, but these three are the same, but this one is different. So no, discontinuous. I can make it continuous by changing a single value, that is moving this point and bringing down here and then filling up this point. It is possible. So this discontinuity is called removable, but in any case it's discontinuous nonetheless. Now another point at x equal to 3. Alright, we have done this before, so we can go ahead rather quickly. Alright, function value x equal to 3, so this point, what's the y-coordinate value? That's 1. Alright, now left hand side limit 3 minus. Follow the graph from the left hand side, and which y-coordinates am I converging into? Y equals to 2. Remember, function values and limits are all y-coordinates. Now x is approaching to 3 from plus side. From right hand side approaches 3. And which y-coordinate? I'm getting -1. And then how about the limit? Limit does not exist because these two values are the same. These values are not the same, excuse me. Therefore, we cannot possibly have common value. The limit does not exist. Determine all x coordinate at which f is discontinuous. Well, x equal to -4, there's one. X equals to 3, there's another. That's because the function value and all those limits are not all the same. Here, 3 of them are the same, but the first one is different. Here, they are all different, and the last one doesn't even exist. And all other points, they're all okay.